Alrighty, folks. Happy Thursday. Hope you're doing well. We're back to winter weather again, so that's fun, right? I don't know. Is it like freezing rain right now? It looks like it's kind of gross out. So hopefully it's not too bad. We'll see by the time we're done. I don't think we're going to spend a huge amount of time tonight here. We got two main topics we want to get to. So in this advanced C#, we're kind of hitting the last little bit here. Oh, let me close down all my other stuff here. You don't need those tabs, right? So advanced topics, we left off. I don't think you need me to tell you about files. Is that a bad assumption, or is that okay? If we just, it's here, you folks can read it. You did files already. It's easier in C#, but the whole concept's the same. You open it, you read, write it, you close it. Life is good. So okay, yeah, they're pretty easy, straightforward. The interesting stuff gets to query expressions and Linq. I'm sorry, yeah.
Do you want to for this particular asking? Is there something like Python-esque where you're using with open, where it just sort of like reads it, closes it on?
Yep. Yeah, so you can use the shortcut for your handler, so you don't have to remember to close it every time. Definitely. Yeah, I think it even has it in here. Well, he's got the with, or it's using in C# land. I think he's got it in here. I don't remember. Oh, is he not? I thought he had it. Using. No, okay, he doesn't. So yeah, so C# using or files. Maybe we should have asked the chatbot. But you say using whatever you want here for doing your file IO stuff, and then when you end your block, you make sure it closes and disposes all the resources for you. So yeah, it's a nice little handy. We make sure we clean up after ourselves and not forget. Definitely a good shortcut. Yeah, so the advanced stuff, then we still need to get to. There's a lot when it comes to query expressions. This is super cool, and we're actually going to keep using this when we get to our database stuff, because this is a very common way to interact with databases using this Linq syntax here, our query expressions. And they'll spend a lot of time on threads and asynchronous programming. Not too much on the rest of it here. Just these are like small little topics. Figure you folks can cover interesting stuff, but the bulk of tonight will be query expressions and Linq, and then threads and asynchronous programming, and then we can get out of here tonight, hopefully before it gets too yucky. That sound good? Sweet. All right, awesome. So with query expressions, if all you folks take a database course, right? Is that 411, 412, 420? 400 some 400 level database course, right? So you may or may not have taken it yet. Has anyone taken it yet? We got one? Okay. Okay. So none of this will make any sense then, and that's okay. So this is all essentially words from structured query language or SQL, how we interact with databases. And we're pulling them into, because this is a query, into C# land. Now, this is one form. I don't actually like this form. I prefer the Linq method expressions. That's what I see more often. So we'll talk briefly about this, but the same concepts apply. We just use them as methods instead of this crazy syntax. So the idea is that you can take something that's a collection. And the idea is any sort of collection that is enumerable, which is pretty cool. So anything that is enumerable. So all of the, not all, almost all the data structures that we work with, probably all of them actually, are going to be enumerable. The idea is you can go over one at a time. Like grab one, do something with it. Grab the next one, do something. You can enumerate each of those values. Grab one, grab the next one, grab the next one, grab the next one. So if you can put it in a for each loop, it's enumerable. It will implement that enumerable interface of whatever type it is. So anything that is enumerable, we can use Linq on. This is system.linq, which is really cool. So it gets more interesting when we do interesting lists. So let me open up Visual Studio. This is week 7 here. So I'll start a new project. Nope, not the installer. Why? I almost never want the installer. I think Windows should be better about that, but maybe not. Let's make a new project. And make sure we're in C#. Should we just do a console app for now? Because I think a console app will probably be fine. Trying to throw stuff in a form might be a little more trouble than we need. So we'll throw it in here. All this week 7. This is Linq here. Oh, I'm sorry. I can see chat, Wolf. Okay. So we'll talk about files when we get to the async stuff. So we'll do some file examples when we get to async, and that'll give us a quick review of files. Does that sound good? All right. I have it up on the other screen, and I forget to look at the other screen sometimes. I can close down the installer here. All right. Awesome. So if we were to make some sort of list of, say, integers here, some numbers, and throw some numbers in here, 7, 8, 9, sure, that's probably good. Oh, sorry, new, what am I doing wrong here? New list of int. Okay, really thought I would just know that. Okay, that's fine. New list of int. So I've got this list of numbers. So one of the things you can do, you can get back a collection of these things. So I can say, hey, I want an enumerable of type integer here is going to be my result here. It's going to be my result. And then I'm going to take this numbers thing and I'm going to do something interesting with it. So some of the things you can do are you can use these different query words. So the idea is you're going to select what you want back out from what collection. So the select says, I want this particular result, and the from is what are you getting it from? What is your collection? What is your enumerable something here? And we start with those, and then you can add in other really cool stuff. You can say, hey, where something's true? I only want some of these things. And this is where it starts to get really interesting. So instead of building a loop and doing this by hand, we get a quicker expression to do this, which works out pretty nice. So I'm going to say, I want to select, select. It's just the word select, just select. Value from numbers. Let me, it's not pulling in Linq, hang on. You want, yes, no? System.linq. Doesn't have it. Why? We have our, we have it. Oh, I'm backwards. From numbers. There we go. Select value. Value. Missing more keywords, friends. From.
Does it have to be on 2 separate lines?
No, the lines here, yeah. I don't use this form here because I hate this form. That's okay. So from value in numbers. We have to select value. So this is essentially like a for each loop. We could say for each int value in numbers. I'm going to do something with that value, right? So I can make a IEnumerable. Actually, I can't make an IEnumerable result, which is really funny here. So you can't say this is IEnumerable of int result here, because then you can't do anything with it. You can't make a new IEnumerable, right? You can't implement an interface, right? Because it's an interface. You can't actually make an instance of it. So the IEnumerable result is like it fits one of these things. We don't actually know what specific type it is here. So generally, I just like list for everything because list is easy and list is enumerable here. We can make a list of type int here, new list of type int, and then for each result, then we could take our result and we could add append the value. So this is the slow way here, and slow is not even the right term here. It takes more lines, or faster is not smaller, easier. Linq result. How about Linq result? With a Linq result, we do the same thing. Now, again, these don't have to be on different lines. It's just generally you do break these things up as you start adding more. We'll call them clauses. As you add more things to your Linq query, you put them on different lines just to make it easier to read. There's nothing wrong with it the other way, but it gets the same thing. So this will give me the same result for each of these. Just going through each number, putting it in. Again, not very interesting. So maybe I wanted to say, hey, if my result mod 2 is 0, then I want to go and append the number here. I'm sorry, value mod 2. So this will be now even numbers, right? And maybe I call this even results, just to make that a little more clear. So Linq. So to do that in Linq here, then we're going to add a where clause. We're going to say where value mod 2 equals 0. Nope, what am I missing here? I hate the syntax, I'm sorry. We will get it where. Okay, where goes first. Where value mod 2 is 0, select the value. So it just gives you a more concise way of putting all this in here. There's nothing wrong with doing it this way, but people like Linq. Again, this is the more verbose style with Linq. Using Linq extension methods is much more common here. We'll look at those in just a second. So does it make sense how they do the same thing here? We get interesting syntax. Looks really funny. If you have done SQL, it'll make a lot of sense. If you haven't done SQL, it looks like gibberish. And we'll just try and follow along because, from this collection, I'm going to call it value. Where this thing is true, right? If this is true, go select this out. And again, this is just integers. It's not anything very interesting yet. We'll add some more interesting stuff in a little bit. But the other syntax here you might want to use is we can say, hey, I want an IEnumerable of type integer. Yeah, SQLite. If you're dealing with SQLite, that's a SQL database you can interact with. Yeah, it's like a loop, copies everything through. Yeah, and you can do, I don't know, more is not the right word for it. So if you just wanted a specific value from the list, you would just go get that value out, right? We just start list dot, find the index of it and get a particular thing. I mean, you could say where value equals something specifically, like this if clause, the where clause. It can be anything really. We'll say this is our Linq methods even results. Now this one, we're going to use these extension methods. Remember we talked a little bit about extension methods? So I want to select. Now, it gets a little funny looking here. So we use a lot of these lambda expressions. So we're going to select something. So I want to say, what do I want to select? I want the value here. No, hang on. I want select the select my value. And then we can add a where the value. value mod 2 equals 0. There we go. Sort of fits here. So, and these can get a little funny as well, but you're going to see these extension methods. So the Linq library has extension methods that they've added, those like public static methods, to anything IEnumerable. So if something's IEnumerable, they added an extension method that says, hey, you can use .select. And .select, you give it a function. Right? .where, you give it a function. Those built-in delegates they were using before. So the function is, hey, give me the value, and then where the value is mod 2 equals 0. Right? So for a given value, we'll do this thing here. And then we should be able to loop over these things and say for each int, how about value in my Linq methods results, console write line, the value. We should get out the even ones if we did everything right. Let's see if we get out even numbers here. It's possible I broke it. All right, cool. So we got out some even numbers. I was a little relieved. Sometimes this is a little funky here. So this extension method syntax, we kind of chain these values together here. Where this is like one query, one clause here with a bunch of these different statements in here. We just keep on adding .select, .select, or .where, or there's a bunch of these really cool methods you can use that let you do things. So there's any, you can do some other interesting ones. Intersects, you can group by, we'll get to group bys later. Single, we'll get out just one of them. We get a single value back out. You can skip certain values in the list. Say, hey, I want to skip the first 5 values, and then I want to do something. You got lots of really cool things we can do with them. You can take a specific number of values out of that collection. Hey, give me 5 of these things and do something with them. The where clauses are our most common one. We're going to use this to specify, essentially it's an if, right? Where this is true, I want these things back. So with just numbers, it's not super interesting. But if we're going to make a class here, so we'll have a class for, how about, what do we want here? Student, a class for student, right? So I'll just have a public string for name, and how about public double for score? Score, and we'll just make these gets and sets. Doesn't need to be anything super interesting. Just get and set, get and set. Closing curly brace. No, okay. Must contain a non-null value and exiting the constructor. Yeah, we don't have a constructor yet, so sure, we'll add a constructor. So public student, that takes a string for name and a double for score. Name is name, score is score. Cool, now it's happy with this. Now, again, I think it usually prefers these lowercase strings, which look blue like primitives, but they're not primitives. It's just a weird wrapper thing. All right, so we got a class. Oh goodness, did we break this because we added a class in here? We probably did. Bummer. Let me just move this here. Add another file. Call the student. All right, now we should be able to use student. So if I make a collection of students, here I can say, hey, student Eric is a new student. And why is it not like student? I'm not picking it up. My goodness. Okay, sure. Oh, we're missing our package here with the top level stuff. All right, so let's make a new student. And this is Eric. And I'm going to give myself 100 because why not? I can score myself. I'll make another student. Let's make Jeb, new student. I told Jeb, he's my son, he's 15, that he should follow along online. He's like, yeah, Dad, that sounds like fun. He hasn't done any of the work though, so he's failing the class currently. But you can't actually get a real score for it, so I guess I can't feel that bad. That's fine. But so he's not doing so well. We'll give him like 25 here. You know, he's at least like looked at the quizzes, right, or something. Oh, I can't even spell EJB. Jeb. There we go. And then let's add Bob here. New student, and Bob. And Bob's doing okay. Bob's got a C here. That's fine. And what's even suggesting here? So when you have properties, that's in our student file here, you can use a simplified expression. Come on, give me the hint. Hit enter. There we go. We can just say, hey, I want a new. You don't even have to say it's a student. Sure. So we saved a little bit of typing. Why not? What else can we do here? We want to wrap. I don't want to wrap every argument. No. Okay. Sure. That's fine. That's one option. Did you see the initializer syntax? I don't know if we went over that before. That ring any bells? Say new student, and then name equals Bob, score equals 75. And what is it now? Like new student? What do we need here? Let me give it just new. No? Oh my goodness. Why am I missing this? Student? Missing my syntax. Oh my goodness. All right. C# initializer syntax. Can't even spell. Can't even spell. Object initializer. New cat. Yeah. Isn't that what I had? New cat equals new student, name and score. Parameter name. There's no argument given that corresponds to the required parameter name of student string double. Broke it. The cat. Oh, because this has a default constructor. That's why. Sure. So if we add a default constructor, maybe that'll make it happy. Student name equals empty, score equals 0. Is that happy now? Yeah. Okay, now it's happier. All right, so if we have the default constructor, we can go through and use the initializer here, initializer syntax. That's just a fun different way. Okay, now we need to put them all in a list. So here's our, how about our list of type student? Then we'll call this class equals a new list of type student, and then let's just give it some values, right? So let's say here's Eric and Jeb and Bob. Oh, I can't use it class. Class list. What class list? There we go. So throw all those students in a list. Now Linq becomes more interesting because now I have objects that have properties. So if I want to get some IEnumerable of type student here for my students, I don't know, how about we say the passing students equals. So I'm going to use the method syntax because I prefer that one. Is that okay? We're going to say my class list dot select. We want, what do we want to select? Well, we want to select my student, where, and let me bump this down here. So this is our class list select where student.score is greater than or equal to, was it 64? Is D passing? I think a D is passing, but it gets you on probation if you get too many D's, right? D plus? D plus? Sorry, what? I was just saying D. Okay. Yeah. So I think if your score is 67 or higher, you're technically passing. So that just a funny story. What do you call the doctor who was the last in their class in medical school? I don't know. Doctor? Do you know what, like, if they graduated first of their class, top of their class, middle of their class, last of their, they graduated, right? Do you know if your doctor got D's in med school? Do you care if your doctor got D's in med school? Maybe?
I feel like med school the bar is high enough where it's like, well, if you have to look something up here and there, it's still a very, like an echelon. You know what I'm saying?
So as long as you passed med school, right?
Really?
It's good enough.
They're pretty stringent. I have talked to.
Yeah, that system is real bad. The residency that they put people through sounds awful. Like 24-hour shifts at a hospital for 3 years or some nonsense. Like, And the idea is that it's supposed to train you to make decisions under pressure. But doctors are the people who study like brain stuff. Wow, I'm good with words today. And like the longer you've been awake and the more tired you are, the worse you are at making decisions. You don't get better at that just because you've done it. You're just literally bad at it when you're tired, right? Like, so I don't know. Don't ever go to the hospital like a couple hours before shift change. It's a bad time to be there, right? Go when you get the people in fresh. So, all right. So now we can get out using this object. We get some interesting values back out here, right? So say, hey, where the score is greater than 67. Again, we're not really getting anything different that we couldn't have done in the list with an if clause here, but it's kind of nice here. And then what we can do with our select, we can actually change what we're selecting. And so say I want to have just this is a type of string here. I'm going to select then, we'll do a little formatted string. Here we'll take student dot name and student dot score. So we'll select, we're going to make up a string that we're selecting here. Oops, I got to do this where first, sorry. I'm in my backwards order. Dot select. So we'll do our where clause first, then we can select from the things that are left these results. So if you put the select first and you turn it into a string, when you're in your where clause, it's working on strings because you have an IEnumerable string, right? This happens in order here. We should do our where first here. That's right. We should do this better. Numbers, where, select. Okay. That's a little cleaner. So now if I want to loop through my list of strings, right? So for each string, I don't know, student in passing students, we can console right line the student. And we'll get their name and score. So we should have 2 passing students. Because Jeb's not passing here, we get Bob and Eric. So we can work with our objects using where, and you can have multiple where clauses as well. Now you can throw all the logic in one line with ands, or you can just have multiple wheres. Just a style preference essentially at that point, right? You know, in here we can say and by student dot, I don't know, name is Eric, or anything else you wanted to add in these clauses here. You start adding in. So as we deal with collections of objects, this is a quick way for us to work through those collections of objects and find the one that we're actually interested in, or we care about. So in his example, right, as you go through the game objects, hey, maybe I want the ones where their hit points are greater than 0, or for a specific player. Right? We can then get all the different objects that we need to care about for this particular game. We can do something with them. Or hey, let's get their hit points. Right? How about the current hit points divided by max hit points? That's the percentage. Right? We got lots of cool things we can put in here. Again, nothing we weren't doing or couldn't do with a simple for each loop. But it's a little more concise here. And we're all about making things a little easier to type out, if that makes sense. So select, where, those are the usual ones, and then other cool things you can do, you can start ordering by things. So you can say, hey, I want these in a specific order. In the result list, order them this way. Right? Kind of like a sort, but we can specify what do we want to order them by here. Okay, so order by hit points, or order by hit points descending. So you can, the normal order is ascending, right? And then if you want it opposite, you want the largest first, you can go a descending order here when you're doing these things. And you can order by more than one value at a time, which is fun. So this is all stuff you can do in SQL, and these sorts of things. It all translates over with Linq. So hey, I want to sort by this one first, and then by this one. So if I have like a list of customers, I want to sort maybe by customer city, and I want to know all the, and then from there maybe I want to sort by alphabetical order. We'll say, okay, where's all my customers in Dearborn? Where's all my customers in Detroit? Where's all my customers in Farmington Hills? Where's all my customers? And then from each city list, then we'll have our alpha sort. Or but really by anything you want here. Right? We can sort anything you put in here. We can sort, and you can start chaining these things together if you want. Right? So we'll order by hit points, and then where the hit points is greater than 0, and then order by doesn't really matter. It just that gets a little more complex here. So the method call syntax, right? Where dot order by dot select, whatever we want to get out here. You start getting these things, and then usually you'll see people use var. I think we talked about var. You don't have to tell it the type, it will infer the type. So instead of typing IEnumerable of type string, I can just say var, and that's a lot easier for typing. That would have been a lot help before coding the Hold'em class. Yeah, there's some cool things you can do in here with the Hold'em stuff. And if you think back to Yahtzee, remember that first version of Yahtzee that the chatbot gave us was using Linq. Right? We should take a look at that again because maybe we'll understand what it was doing if we go back to that. I think it's still in my history. We'll see. Yahtzee scorecard. Yeah, look at that. It still is here. So the first version here then, I said, okay, what am I counting a score here? Well, I want the count function of for a given die, where die equals the number, times the number. So the count function is going to tell you how many times this happens here, right? And then multiply by that number die. So we can use this count score for any value, right? Does this one make a little bit of sense now? There's a group by function. So group by will group the results together here. What you get at, sorry, phone should be quiet. Yep, let me put that on vibrate here, sorry. So group by gives you a collection result. So I wanted to group my students by here. So let's add another student here. Let's add a student. Who should we add? Let's add BB here. A new student. And then we'll just do this. We'll say name is Vivi, and then score. Let's give her 75 as well. Why not? So if I want to group my students, that's my wife calling. She knows I'm in class. Hang on. She needs salt. All right. If we want to group the students, say by score, here we can get out all of the students who have the same score in a single group. So let's say I want to var, this is students by score, or group by score. So my student list, passing students, nope, this is just my class list dot group by, and we want to group by the student score. Now, but what is this? This is an IEnumerable of an I grouping of double and student. Doesn't seem like it'd be super useful here, right? But we're getting out a grouping of double and student. So we have a collection of groups here where we have double and student. So then this any clause says, hey, if this is true, if any of these is true, I want to do something. So if any of the groups have a count of more than 3, any of those collections we've grouped together is more than 3. So in our case, we can say dot any, and we want student, and then we want group dot count greater than 1. So now this result here is just a Boolean, because any is going to give me back a true or false here. Is this true? Are any of these items, this is true? So if this is true, I have two students, at least 2 students with the same score. And so it's sort of a silly example where we can group these by and then look up something about those groups if we want it. So that's what this group by is doing. So if we have a group with 3 or more, then we get the dice sum. Otherwise, your score is 0 for 3 of a kind. A little convoluted here. Same idea for the 4 of a kind. The full house. Now, this one is grouping by the die, and then we're doing 2 things with our groups. We're saying, hey, we have 2 groups specifically, and one of the groups is a group of 3. Because if we've grouped all the dice together by their value, right, like we did here with our group, and we have only 2 of them, and one of those groups is 3, the other one must be 2, because we only have the 2 groups. So we get a score of 25, if not 0. Has straight. We're going to skip I, so starting at 0, going up to numbers length, minus length, plus 1, I plus plus. So when length is 4, here, right, if we're looking for a small straight, we have 4 dice of this in order here. So here's the numbers, 1, 2, 3, 4, 5, 6. So starting with numbers, right, we're going to skip how many? So when I is 0, we skip none, and we take the length, right? We take 4. So we'll get 1, 2, 3, 4, because we've skipped none. And so that's skip, right? You can jump past as many as you want, and then you can take, says go get this many. So we skipped over none, and we took 4 in a row. And now we're saying, hey, we intersect. So the intersection of my collection and your collection, if that count is the length, if we have 4 intersected here, we have a small straight. If that's not true, then let's I plus plus, I goes up by 1. Okay, now let's skip 1 and take 4. So now we have 2, 3, 4, 5 here. And now let's see what the intersection is. If the intersection is 4, you have a small straight. Okay, not there. Skip 2. Let's grab these 4. Take these 4. Do we intersect with the length of 4? So this is actually it gives us lots of cool examples of using Linq right in here with this project. Okay, and if none of that's true, we return false, and it works for 5 as well. We're going to skip 1 and take 5, 1, 2, 3, 4, 5. Skip 1, take 2, 3, 4, 5, 6. The next time, do we intersect? Where our number of intersected values is the length. Yahtzee, do we have a group of 5? Sure. I mean, we could also check when we group by, is the count of groups 1? Right? Do they all group into a single group? Differently, we could have written it either way. Both works here. And then chance is just the sum. Oh, we didn't even finish this one, right? I don't think we, is that done? I don't think we have a sum. Yeah, didn't we give us all the code? Look at that. We didn't ask for the rest of the code. Oh no, I'm sorry. Dice sum is sum's a method. I'm sorry, because dice is the list. Yeah, so you can automatically sum it up. So we can do that and get the sum of dice. So then we ask, can you do it without Linq? Right? We got our version that we did work with. Now, is this easier? Maybe. I mean, some of these are cute. Like, hey, let's group them together here. Doing that by hand would be obnoxious, right? To try and group things together into groups and count how many items you have in the groups. We could do it, right? Could we do that by hand if we wanted to do our own groups? We could, right? So this is what? I don't know. This any was silly. So this is my var. Multiple students has multiple students with same score. Okay, that's because we did this any clause. That's all it was doing for us. So if we wanted to do our own grouping here, well, we need a place to store those groups. So I need a list of what? Well, the groups are really, I'm going to have the value we're grouping on and then the list of students. Right, so really that might be a pair. Oh, sorry. I want a pair, right? Can I just do pair? Can I do key value pair? Sure, key value pair of type. So what are we grouping on? Well, we were grouping on score. So of type double, and then the next value was student, list of students, right? List of type student. And we have a list of those here. This is my groups then. The new, is that not, okay, what is it not like? Key value pair, double list student is a type not valid in the given context. Why? It's not valid. Why does it not like it? Oh, my greater than signs? Ah, thank you. Yep, missing another. There we go. Oh, there's 3 here. Thanks, Fluffy. All right, so equals a new, right? Sure, one of these things. All right, well, now we need to go through and look at every student, add them into, based on what their score is, add them into the group. Sure, so for each our student in my class list, we need to go get their score. So we'll get their score first. So double for score is my student.score. And then if my groups dot, and then this is the key value pair, right, inside of it. So if each one of these, right, so for each var group in, let's see, this is in groups, right? So for each group in the groups, if my group dot key is equal to the score, then we have a match, score, lowercase score. If it's there, then I'll take my group dot value. I want to add the student, right? So if I find one, and again, this gets really ugly because we're trying to like put all this together in a list of collections of things, and this is gross, right? It's doable, but it's kind of gross. So if I find a double, which is my key, that matches the score, let's add the student. If I've gone through all of the groups and I haven't found one that matches yet, I'm going to take my groups, I'm going to add a new key value pair given the score and the student. A new list of type student given the student. Right? Oh goodness, not too many. Student. Collection initializer because it's not implement a enumerable. Add a new key value pair, double list student. Okay, sure. So we can't use the initializer. That's fine. Why can't we use the initializer? New key value pair, given score and new list of student, given the student. Is that happy there? All right. Wow, that's long. Okay. So we'll go through. So this is if we didn't do that, right? So if it wasn't in that list, we want to do this. So if we did add it, we want to be done, right? So maybe we'll go and continue. Continue. If we didn't continue, then we'll go and add the group, right? I guess sometimes the continue word's okay. Usually I don't like these things, right? So go to the next one in the group. Oh, that's not even gonna, no, that'll continue this one. Oh, bummer. All right, so we need a Boolean for, I don't know, new group equals true. And then we'll set new group equal to false inside the loop here. And then if it needs to be a new group, if new group, then we'll go and add the new group here. This is fun, right? You folks don't look like you're having fun. All of this work, right, to essentially use a group by. Mostly the same. Again, it's ever so slightly different here, but we're getting close, right? This is why people like Linq, because you do cool stuff like this, and it just works. Right? Let's group them all together. Great, we're good to go. I don't have to worry about all these funky how I want to store these things or what I want to do with it here, and go off of that. Right? We okay so far? Maybe. I think I lost you like 15 minutes ago. All right. What was it? The group by, or was it like just when we started the like where and select stuff? Okay. All right. Cool. We'll try it. We'll keep going. So selecting stuff out, counting. So any means where anything is true, or all means everything is true. So I could, check, does every object in this collection meet this condition? I get a true or false back. Or does any one of the objects, so kind of like an and an or everything anded together is true, this and this and this and this and this and this and this, or any is like this one or this one or this one or this one or this one. Does any of them or meet this case here? If you like to think of ands and ors. We did skips, we did takes when we we're looking at our dice here. You can real quick get average, min, max, which is fun. So I can find the max score real quick. So our highest score, so var, now to get the max here, we're going to get back a single result, right? I'm not going to get back a collection here. So really this should be a student here. This is the highest score student. Should be my class list max of, well, student, what? Student dot score. Let's find the max score here. And then my var is just, that's just the double, right? I got the double back out. Well, I don't want just the double result, right? I want the student back out here. right? Let's see, so this is, I think we can get min and max. Just gotta get the objects back out. So we could say dot where student score is, I guess we need to get the max first, right? So we get the max first. Okay, so here's the highest score. Class list just max. That will do this. Then we can come back and say our students. So I guess technically you can have more than one student with the highest score. So it could be a collection, right? Two people can have an A, can have 100% with highest score. Score my class list dot where student dot score is equal to the max score. Highest score, highest score. There we go. For each student and students with the highest score. Look at that. I'm going to print out the student. No, console. Not right line. There we go. So who has the highest score? Oh, week 7 Linq student. There's no toString, right? Our student class didn't implement a toString. Oh, bummer. We can go do that. So in student, right, we'll go add a public override string toString. Look at that. I love it. Do a formatted string name, I don't know, or name equals name colon name and score colon score. Let me find the right key here, score. Now it'll print out nicer, right? Yeah, Eric, score 100. And if we had more than one student with the same score, if anyone else want 100, we can throw you in here. Throw in another student here. Who should we give 100 to? Maybe Jazz wants to take my class. Jasmine, give her 100. Uh-oh. Did she not get 100? Oh, I never added it to the list here. That's why. Evie and Jasmine. There we go. Let's add all the students in here. Gotta add her to the class. There. Now she gets a better score. Or now she's up there with the highest score. So if we wanted to, right, to not write this all at one, here, we can throw this in instead, like that. This is even uglier, but sure, it works. It's equal to the class list max of this. Just do it right in line here, right? We don't have to have a separate variable for it if you don't need it. You can just add it in. Linq's a lot of fun. You can do some fun stuff with it. Yeah, average, sum, max, cool. You can do all those. You can select over more than one selection of objects here. So, hey, I want to go from all of these objects and all of these objects in the same query. Right? I've got two different collections I want to work on now. Let's do something. Right, as long as they're not the same, if they're colliding, or whatever this colliding with method is. So we've figured out at some point if these things run into each other here. Now, the problem is, though, you get what's known as our Cartesian product. You get, for every one of these, you get every one of these, like an inner loop, right? So for every object in O0, and then an inner loop for every object in O2, let's look at that. So if you've got 10 objects in O1, 10 objects in O2, you get 100 runs, right? Which is fine, but if you're dealing with 1,000 game objects, right, now you got a million things you're running every loop here is probably going to be a little slow. Probably not ideal, right? So we need some better ways to deal that. But if you have multiple collections that you want to join together, we want to find where they match, right? So say, hey, I've got a collection of teachers, and I've got a collection of students, and I've got a collection of classes, right? At some point, the teacher is assigned to a class, and a student is assigned in a class. We can join those together and find the student and the teachers, or the teacher and all the students for a given class. We can join them together and do something with it here. What if we want to select back out when we're done? We can get all these things here, which is really fun. The let clause lets you add more variables, essentially, right inside of your function, or right inside of your call here. So instead of having to calculate your hit points divided by your max hit points, inside of wherever you want to put them here, we're going to add essentially a new variable. This one didn't exist before. We only had objects. We only had the properties of objects, but now we just said, hey, I have a new thing that I've calculated here. Then this continuation clause lets you essentially build a new grouping here. So I'm going to grab all of these first and then store them as object health. Then I want to work, this the next part of my query works off of this next grouping. We already chained ours together when we start doing the wheres, like they're dots and wheres, so we don't need any of that. But you can go through. Or you can just write it as two separate queries here. Actually, the grouping by, you can group these joins together. So when we join these together, right, we're essentially grouping them. Don't worry too much about that one. And then what's fun about Linq here, it actually does the deferred execution. So as it enumerates over, it runs here. So as we ask for the values, it will go and get the values back out here, which is nice. So if you have 10,000 items, it doesn't need to load all 10,000 items into memory right away just to loop over them here, right? We don't have to put them all into a basic array to look at them. We'll just load a couple at a time as we're using them. But if you want to get them all at once here, you want to turn it into a list. So now that we have the list, we've got everything loaded, ready to go here. For our purposes, we probably always want everything in a list. But imagine if we're working, and when we start working with databases, if you go, hey, I want to get a list of transactions at Walmart. If you just ask for all transactions at Walmart, you're going to get millions, right? Probably even a day, right? I mean, across all their stores in the US, probably 1 million transactions a day. I wonder now. Do you think Google knows that? How many transactions happen at Walmart each day? I'm curious. Oh, 300 million items every day. That's more than I thought.
I know it's one of the like leading businesses of revenue.
Yeah, they sell a lot of stuff. Go figure. Okay, so if you wanted to just get all their transactions, that's probably a bad idea. But if we wanted to go through and say, hey, show me every transaction that was more than $1,000, right? We can start going through. We don't have to load all of them all at once. We can get a couple at a time, look through as we go, as we start enumerating over them, right? So if you put all them into a to list here, you've got it loaded, right? If not, we can kind of lazy load these things as they go, defer that execution. It's nice. So it just kind of depends on what we're doing. And then when we get to SQL, when we start doing our database work, we're going to use Linq to SQL, which is fantastic. So this is language integrated query, Linq here. It's not the only way to interact with the database, but it's fantastic. It works out really well when we start doing all of our database work. So all these same ideas work when we start talking about databases, because databases are really just a collection of objects. If you haven't taken a database class yet, that's okay. Don't worry about it. Have you folks used Excel ever? I really don't know these things anymore. Right, Excel's a spreadsheet. You have rows and columns.
Yeah.
Okay, I don't want to jump too far ahead here, but let's see. Right, so essentially you'll have, hey, I'm going to have name and I'll have score, and then every student then, right, we have Eric and score was 100, we have Jeb with 25, we have Bob with 75, we have BV with 75, we have Jasmine with 100, right? You get rows and columns. Let me zoom that in, sorry. So each column is essentially an attribute, right? And each row is an instance of that object. Not entirely the case, but that's essentially how it works when it comes to databases. So there's some other cool stuff we'll talk about when we get there. But as I'm working and getting data out of the database, right, I can just use Linq just like we're working with collections. We just have a collection, right? whatever this every row is an item in that collection. They start getting these things back out here. And then databases are fantastic, right? Because so far, I guess we briefly talked about files. We'll come back to files in a minute. The data in our program only exists while it's running, and we shut down and it's gone. So we can't really do anything interesting because it'll just go away when we're done. Right? It'd be a lot of work to put it all back in and start it back up every time. So once we have databases, that's really where stuff is stored. Now, files are still great. We still use files, and your computers all have files, and that's all fine for local things. But any sort of enterprise application is going to put data in a database, because they need a central repository for that data, and databases give you all sorts of other really cool things that they do with data to protect it and back it up and maintain it and protect its integrity and all these good things. Relational database management systems are fantastic. They do lots of really cool things, and everything runs off of a database nowadays, right? No matter what we do, your data's in a database somewhere. I think I've said database way too many times now. The word has lost all meaning. Database, 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 database. You know where dads keep their jokes? In a database. All right, with that, why don't we take 10? I'll come back and we'll pick it up with threading. Sound good? All right, folks, thanks. That was a pretty bad joke. Back at 7:07 or so. Welcome on back. Hopefully you got your snacks. I got my Diet Coke. Life is still good. We're good here. All right. So before we jump into the other new stuff, I did want to make sure we talk about the midterm. So the last time I taught this class was 2020. I don't remember much of 2020. I'm going to be honest here, but it was a bad year. It was a real bad year. So you're going to see something here in the beginning that I'm not offering you folks because it's not as bad as 2020. Okay. So this is the practice. This is the last time I gave it. I'm going to rewrite it here. This first part does not apply, just as my caveat. Okay. Because we didn't know what was going on. So I just said, sure, go for it, because we'll just get through it and it'll be okay. All right, it's still loading in Canvas. That's fine. I've got it right here. I'll just open the PDF. So, question 1, you agree to the academic integrity policy, right? The work that you submit is your original work, unless otherwise cited. Violation of this means you fail the class, get reported to the dean's office, bad stuff happens. We've talked about this before. I complain about it all the time because I still don't know why I have to fail someone every semester. I don't understand it. I really don't, but that's okay, right? I don't have to understand. Everyone can make their own choices. This is the part that does not apply to you, right? This was 2020, and we just said, let's just survive, okay? So this does not apply. That's my big caveat, okay? No group work. We're okay? All right. So other than that, quiz style questions, true false questions. I use the exact same test bank. I just say, hey, randomly pick 30 of them. That's it, right? They're the exact same questions. I don't even bother rewriting them because these are the true false. So I used to have other questions, and then I learned if it's not true false, like even if it's short answer, the auto grading sucks because not everyone typed the exact same letters. And if I want to do like every single variation of things you might type, whatever, and then I'd have to go look at it anyway. And it didn't grade it for me, so I had to go manually grade all of these things. And there were like 45 people in the class, and I didn't have a grader. So I gave up on these. That's okay. The quizzes were for you to go open the book. If everyone gets 100% of the quizzes, I'm happy. Really, I'm happy. Like it's meant to get you to open the book. That's entirely the reason why I have quizzes. So you'll see other questions like that. So you can basically ignore the quiz questions if you want here, because they're going to come out of your quiz test banks, right? All the quizzes we did here. I'm just going to pull out of those. So about 30 of those or so, and then we get into long answer questions. So there's actually 31. Sorry, the academic integrity question was 1, and then 30 more. So 31 points for the questions here, and then a couple short answer style. So the midterm is next week, 2/23. So it'll open at 6 p.m. and the due date will be 3/9/6 p.m. Ideally, you can sit and take it in one night. It's designed if I want to sit and watch people take tests, we can do that. I don't want to do that. Okay, I have no plans on coming on 2/23 unless you want me to come and sit and watch you take a test. I'll sit and watch you if you want. It's weird, but sure, that's okay. Just let me know. But I don't plan on coming because no one ever asks me to watch them take a test. One of these days, someone's going to do it just to mess with me, but no one's done it yet. Yeah, so it'll open up. If you want to get it done before winter break, great. If you want to leave it until the week of 3/9, great. Totally up to you. If you want to do it during winter break, great. It's your break. Hopefully, you've got some time to actually take a break, though. Right? That's good for you to be able to unplug and stop thinking about school for at least for a little while here. Fluffy, if you want to bring lots of snacks and maybe a game, that would be fun. Games would be a lot of fun. We could play Yahtzee. You want to bring Yahtzee? Or poker. We could play poker.
What's the buy-in?
I've got a case of chips. We just can use pretend chips here. My brother actually had some really nice chips. A different hat. Well, I forgot. I usually have different hats at home. I take my hat off. You can see my terrible hat hair. That fair. I got these silly Twitch channel point redemptions. So Wolf wanted me to change hats. Usually I've got a couple different ones at home. So all right. Back to the midterm. Okay. So a couple short answer questions. So this is not too many of them here. And a hydration reminder. Thanks, Fluffy. Gotta stay hydrated. Hydrate before you dehydrate. Okay, so write a method to filter out evens given a list of integers called numbers that returns a new list of integers that contains all the odd numbers in the numbers parameter. Right? Do with Linq, do without Linq. Sure. Right? I think you probably can think of different ways to do this already. We did evens. It was just not 0 instead of 0, right? That was pretty quick. Write a unit test for filter out evens. Did we get to unit testing when we talked about classes? So when you write a unit test, right, the idea is we're going to make sure the code does what it's supposed to do and use the testing framework. Cool.
I think that was the one you did in your own house.
Okay. Yeah.
It was like weather.
Okay. Cool. Write a unit test for it. So you go through, you want to add a new package. So go to your solution, add new project. You want to add test code. So it's search for test. You want an MS test project. New test project. Sure, we'll put it in here. Great. We want to what do we want to test? Well, we're going to test student. So student's not very interesting right now, but that's the class that we have, right? So what do we want to test about? My goodness. Why? Okay, there it goes. Okay, just had to load. Right? You want to arrange, you want to act, you want to assert. Right? Those three things. So if we want to test student, we need to use student. So we should be able to do our using is that week 7 Linq? No. did we do up here, right? Using week 7 Linq, yeah. Is it not public? Shoot. Student test equals new student. Let me see if it'll pick it up for me here. I don't remember what I'm missing. And, oh, okay. So we have to add a reference. It's been a little while. So once we add a reference, this is a project reference. So it says, hey, my project references another project. That's what this link does for us here. Then we can go through and get the student stuff out. So a little light bulb's fantastic. I love Visual Studio. Anyway, so we'll make a student, and then what do we want to do? So we should probably give it a name, and so this will be Eric and 100. Why not? So we want to act. So we're arranging, we're setting up student, and then I'll have a string for the expected, I don't know, student string. This is probably ugly, but that's fine. It'll be name colon Eric, score colon 100. So these are the things that we expect to get here, right? If I know what I put in, I know what I should get back out because you wrote the code, right? This is, so we're arranging and we're going to act. We're going to call the code we're testing. So I'll have a string for the actual student string is my test student. Maybe we'll just call that student. That's probably better. Student to string. Okay, and then we're going to assert. We want to assert equals. Assert equals. Oh my goodness. Assert dot. There we go. Assert equals my expected string, my actual string. So the assert tells Visual Studio that this is what should match here and makes it actually run as a test. So then you can right click and you run your tests here and you get this cool test explorer, should pop up here. I have mine docked over here. If you don't have test explorer, right, go to test and show test explorer. It's been a little while. And it says, hey, here's all the tests here. Uh-oh, this one failed. Oh, assert equal should not be used for R equal. Okay, I picked the wrong one again. Assert R equal. There we go. Let's try that one more time. One of these days we'll learn. I might take that idea that you don't have to memorize anything a little too far, but that's okay. All right, and now it passes. Great. So if it was wrong here, right, and this is very sensitive here. If I miss like my space there, and I run my test, it's going to say, hey, the test failed here. It expected name Eric dash score 100. The actual was name space dash score 100, right? So we can see right away if something works or doesn't work without having to eyeball it here. Remember, that's the whole goal. Unit tests make the computer do the checking for us because it's much better than we are. Just think back to checking your English papers, right? How often do you have the same word in there more than once? You say and you never catch it because you know what it's supposed to say when you read it. People are bad at this sort of thing. That's okay. We can admit that. We'll let the computer overlords do the checking for us. They're a little smarter at that than we are. So that's the unit test, right? So write the unit test to make sure it works. So if I put this in, I get this back out, right? So write a unit test with this sort of arrange, act, assert format. So you just go to Visual Studio, write it, and then copy paste in the method, right? Please use Visual Studio for the midterm. Please don't type into Canvas. I had someone say they typed all their code into Canvas directly and didn't try it in Visual Studio, and it didn't work because they didn't write it in Visual Studio, and I was really confused. Okay, like, use the tool, please. All right, write a class beverage with private data members for name and volume in milliliters. Overload toString to return a nicely formatted string with the name and volume. Cool. Add a constructor for beverage that accepts name and volume in milliliters. So kind of like breaking this up step by step by step. I'm just trying to give people points here and not one big question that's worth 15 points or something. So step by step by step. And then make name and volume public properties with a private set. So we're just kind of iterating on this, changing a little bit here. And then write a class alcoholic beverage that extends beverage. Include a property for alcohol by volume percentage, public get, private set. Override toString to include the ABV information and in the string returned. Write an interface. Okay, so this was like classes and testing, and then inheritance. Right? Then moving on, write an interface, I rock, paper, scissors with the method shoot that returns a string. So interface returns a string. That's all it is. Just here's my contract. So if I'm in I rock, paper, scissors, if I implement I rock, paper, scissors, I'll give you something back when you use the shoot method. Okay, write a class that implements I rock, paper, scissors, but only returns rock. This is the Eric method. I only play rock when I play rock, paper, scissors, and I win more often than I should. It's really like a mental game. If I tell someone I'm going to play rock, then they have to think to themselves, wait, why is he telling me this? Is he really going to play rock? or maybe he's telling me he's going to play rock because then he's going to play something else, and I play paper to beat rock. Maybe he's going to do scissors, and like they just get in their own head, and then I win. It's amazing. I'm like, I told you I was going to be rock. Why'd you lose to me? And then they just feel dumb.
Is that only on like best of one?
Yeah, after we do like best of 3, best of 5, like my kids now know I'm always going to do rock, and every time I play rock, and like they just beat me every time, and they think it's hilarious. They're like, I will only play rock because I'm stupid, and that's fine. It entertains me. It's a thing. Sure. All right, ready class implements I rock paper scissors that randomly returns rock paper scissors. Okay, that was it. So nothing too crazy. You should be able to sit down and do it in a sitting if we wanted to take the whole night to do it here. So similar questions. You always play scissors, Fluffy. That's a bold move. That's a good one. Yeah. Now, does anyone play rock paper scissors lizard Spock?
That's the one. Well, I used to play one. It was RPS 25, and there's 25 of them.
25 different ones?
Yeah.
Oh my goodness.
Pretty good. And like me and my friends used to like print out the sheet of which ones like all the ones.
All right, that is not the one I wanted. Rock paper scissors lizard Spock. Code samples? We can wait a minute. We're building rock paper scissors lizard Spock and putting it in Docker in Azure. Okay, that's a little overkill. We can do this. We can make a web service to play rock paper scissors lizard Spock, I suppose. I mean, anything's fun, like just to try it, try the technology out here. I just want, there's an app here. Just tell me what beats what. Here's the picture. There we go. Rock beats lizard. Rock beats scissors. Rock loses to paper. Rock loses to Spock. Right? Instead of beating one each, losing to one each, they beat 2, and they lose to 2. 25.
Yeah, look it up.
So then you'd beat 3 and lose to 3, or you'd lose to 4 and beat 4. There's 9, right?
Beat 4 and no, not beat 4. You beat like half of them,
yeah.
Then you lose that.
So you beat 12 of them, lose to 12 of them,
like
and tied. Okay, sure. That sounds like it'd be a lot of fun. Scissors cuts paper. Paper covers rock. Rock crushes lizard. Lizard poisons Spock. Spock smashes scissors. Scissors decapitates lizard. Lizard eats paper. Paper disproves Spock. Spock vaporizes rock. And as always, rock crushes scissors. Is that how it goes?
Yeah.
Okay. Anyway, how did we get on that? Oh, our practice midterm, right? So similar ideas. Here's an interface. Go implement it different ways, right? For some fun. Questions, thoughts, concerns? Okay. I really want it to be low pressure. I hate high pressure exams. I hated them as a student, so I try not to do them. And they let me do that because I sit up here now. Imagine that, which is very fun. Okay, so that's out there. I linked it in Canvas. It's linked in the course info, or it's also in the files section if you want to go check out the files directly. It should load eventually. Canvas is just a little slow sometimes. There it goes. 28 pages, so it has to like render the PDF. Just takes a little while here. All right. Okay so far? Cool. So let's go back. So this was week 7 Linq. So let's do another project then for our async stuff. Week 7 async. Okay. Asynchronous stuff is really tricky. It gets really complex. So we're going to start with some basic things, and that's okay. So the idea is that things happen on a thread. So a thread is one working process. And most processors, right, are multi-threaded, can handle multiple threads at once. Whether or not they actually have more than one core, sure, that's something our electrical engineering friends or electrical computer engineering friends could all figure out here. We just know we ask the computer to do a lot of things, and it does a lot of things. So if you look at Task Manager, right, a lot of stuff is happening here. But basically, only one thing happens at a time. Maybe 2 if I don't remember if my computer actually has multiple cores. What does it say? Yeah, it's an Intel i7. I don't even know. I don't even really care. So it just spends a little bit of time doing one thing and then goes to the next thread. Spend a little bit of time doing that thing, goes to the next thread, spends a little bit of time doing that thing, goes to the next thread. So all of these different processes are different threads that are running, and eventually the CPU says, hey, do you want to do anything? No, I'm sorry, the operating system says, hey, do you want to do anything? I'll give you some time on the CPU. Right? I should be better about my terminology. Any of you had the operating systems class? Has anyone taken that one yet? That's another 400 level class. You will have fun with that. And fun is in quotes. It's not my favorite class at all, but that's okay. It's really good that people know how that stuff works, because some people need to write Windows or the Mac OS or Linux OS. They need to understand how operating systems work. I could care less. I just want my programs to run, because that makes me happy. So again, great. Everyone can do things different. Oh, PJ, Buttercup, you took operating systems? Awesome. So in our program, all of our programs up to this point have been single threaded, right? They just run and there's a single thread that operates. So if it's busy doing something, it has to wait for the next thing. So if we do, I don't know, for each, for int, yeah, I is 0, I is less than, let's do a really big number here, 10 million, sure. Console write line, I. And then when that's done, we can console write line, the end. Now, in terms of processing power and speed that things happen, your computer can process things really quickly. What's really slow is spitting something out on the screen. So printing something is very slow in comparison to how fast it can actually compute things, right? So if we hit run here, this is relatively slow, right? If we just, because we don't want to get up to 10 million, that's going to take forever here. If I just take this part out here, it will still do something, right? But it's not going to spit something out on the screen. Maybe we just say I int x equals 10 x plus plus. Right? Let's just do some operation here. It's garbage. We're not going to do anything, but we hit run and we get the end, right? It doesn't take that whole amount of time to do 10 million times 2 operations. It goes really quick. So spitting something out on the screen is slow. That's the slow thing that happens here. If there's a slow process that has to happen, and you want to be able to do other things at the same time, we can introduce threads. Doesn't mean every program needs to, right? It's okay to wait sometimes for some programs, but typically things that are slow for us are writing things to disk. Right? It takes a certain amount of time to tell your operating system you want to write something to disk and for it to actually write to the disk. Maybe that's a good thing to happen asynchronously on a different thread, because we don't depend on it finishing before we do our next task. Depends on what we're doing. So logging is a great example of that. You don't want your program to have to wait to, sometimes, maybe it depends on your application here. You don't want to have to wait for the log to get updated if you're writing to a file on your computer before you can start doing the next task. Maybe it'll say, hey, log that this happened. I'll trust it finishes at some point. I want to keep working. It's a great thing to do asynchronously. Now, you don't do that in healthcare, because healthcare has very specific reporting requirements, and you have to make sure you logged when someone accessed your electronic medical record. Otherwise, you're in all sorts of trouble, right? Because you need to have an accounting of who accessed your EMR, your record. Sure. So just because it's logging doesn't mean we can always do it. Again, sorry, my sugar's a little high right now. I didn't even eat that cookie. That's so sad. All right, let's take a little more insulin. I had a wrap. What time does the cafe even close?
Well, it's supposed to close at 5, but they always close before 4.
Man, like if you have a night class here, you just can't get food.
Maybe I just
That's sad.
earlier like 5 to 4 they got food.
That's sad. You have to know the guy to make sure you can get a sandwich on campus. When I mean, we have other night classes, right? We're not the only night class. There's like actual people around on campus tonight, or is it just us? Are we the lonely folks?
I definitely see people around within the minute. It's always like 2 people.
I thought I closed at 5, not 4. That's why.
Yeah. So the problem with things, right, is that they take money. Really, and that sort of is, and they're a vendor, right? They're not the university.
Mm-hmm.
So if they're not making money, they're not going to do it. The problem is, like, student services, like food service, is a service. It's not supposed to make money. It's supposed to serve the students. Now, it shouldn't lose a lot of money, right? Again, okay, we're off track. I'm sorry. The stuff like that just upsets me. Like, it's there for you folks, and really for me too, because I want food. Like, I don't have to go to the vending machine and get a bag of chips again. That's not good dinner. So, anyway, how do we even get on that topic? Why was I thinking about the cafe?
Like your thing beat.
Oh, my insulin. Yeah. Oh man. Okay. I may or may not have some undiagnosed ADHD, but I self-medicate with caffeine typically. So generally it works, which is one option, right? You don't want to see me on Adderall. I think that's a bad idea. I'll talk to my doctor. Maybe it's a good idea. Although that's hard to get nowadays, right? Don't they still have an Adderall shortage or something? Okay, maybe it's over. It's like a big deal. Like a bunch of my parent friends are like, "Oh, we can't get our kids' meds filled. It's going to be awful." Yeah, feel bad for the teachers. That's a rough couple weeks. Huge back order still, PJ Buttercups. Okay, a national back order. Oh goodness, that's no good. That's like, I mean, it's important medication, right? It's not insulin. Like I will die if I don't get my insulin. Literally, will die. You're not going to die if you don't get your Adderall. You'll just be in rough shape, right? So
I just will be getting my car from this weekend.
yeah, it's okay. We got extra time, right? All right. So slow things are good for asynchronous stuff because we want to continue processing while the slow stuff happens. It's nice. So we can stick all of the work off in another thread and say, hey, you go do your thing. I don't care. Whenever it's done, it's done. Now, if you want to get particular results back, it gets a little trickier and say, hey, tell me something when you're done with this processing. Okay. Well, now at some point, we have to wait for that to finish to do something with that result. That adds another level of complexity, but we'll work through that in a little bit. Other things that are slow are anything over the network or on the internet. Right? Your computer is really fast, but once you have to talk to the internet, who knows how long it's going to take? It's really out of your control at that point because it's up to the network, and then whatever server you're requesting data from, however long it takes to process, and then send it back to you. Now, most times it's really quick. Right? You go to a website, it loads, maybe not like snap fast, but in a second or two, it loads, and we're pretty happy. But if your application has to go out and get data off the internet and then show it to your user and do something and then go get more data off the internet and do something with it, that sort of thing, that might be something you can do asynchronously. Right? We want to load the main part of our application and then say, hey, we're waiting for data, or give them some spinner or something. Users don't like when things look like they're locked or like stuck or waiting or spinning or hung. Makes people unreasonably upset. Happens to me too. It's okay. So if you can at least have something light up and look like it's working while another part looks like it's loading, we're like, oh, cool, it's doing something. You feel like there's progress here. But if your whole application just kind of sits and hangs, one giant spinner, you're like, oh, this is dumb. So like most websites, maybe not even most, but a lot of modern websites nowadays will do this sort of asynchronous loading. They'll load the core of your site, and then behind the scenes, right, other requests will go out and will load other data on separate threads, which is nice. We like that. So things can load and we get data back in, they start showing up on the screen, and we're happy. Like, this is good. We can do similar things with our programs that are not websites, right, with asynchronous loading, asynchronous tasks, and asynchronous work. So we'll start other threads, we'll get some data, we'll do something with it, and then we'll get a result back and show it on the screen. So those are nice things to do here when we're dealing with slow tasks, slow things that have to happen. But it's hard. So usually what we do is we'll start a thread. And so there's like there's the thread approach, and then there's the asynchronous programming approach, which has all the modern features of C#, which is awesome. So we're going to start with threads, which is a little more basic, a little easier to follow here, and should be good to go. So when you start a thread, you say, hey, please go do some work. This is system threading here. So this count to 100, sure, well, whatever here. We have some sort of function, and then you can give your thread a function. So let's just do up to like maybe 100, 10,000 is probably fine here. And let's put all this in a function. So this will be my public void count to 10,000. And throw all that in here. Oh, no, I don't even need public. Okay, that's right. We're using our top level statements. Format ed, control E, control D. So here's my function. Great, we've got it. I can ask for a thread to run a function. So I'll say thread equals a new thread, given count to 10,000. Can't even see what numbers these are. I can put an underscore here, right? Count to 10,000. There we go. Now I've got the thread, but didn't actually do anything yet, right? It's just there. So to start it, right, you tell your thread you want it to start. Let's go start. So I've made this thread object. Thread takes a delegate, right? Takes something. What do you want to give it? Here's the function you're going to run. It's a delegate, right? Here's a method. Go do this thing. We can say thread.start, and eventually the thread will run, and we can go do something here. So I can write line thread started. Console write line. Oh my goodness, why not? CW is the shortcut. CW. No, CW is the shortcut. Console. Why? Okay, sometimes my shortcut works, sometimes it doesn't. I hate that. Write line. Doing more work. Yada yada yada. Sure. Eventually, the thread will stop, or if we want to force it to wait until it's done before we continue on, you can say thread.join. So join waits until the thread is done. So if there's some amount of work you can do while this is running, you just put it in here after you start. If there's something that depends on it being done before you continue on, you can join the thread. Say, hey, go ahead and join, just wait for this one to be done. And then once it's joined back up, it's free, we can keep on moving here. Right line, there we go. All done. Here. So we're going to count to 10,000. Okay, all done. But back up at the top here. Oh, it's too large for the buffer. Shoot, let's just count to 1,000 then. That's sad. That's sad. That's okay. We'll count to 1,000. We can fit 1,000 in here. We see the thread started. We're doing more work, and it actually kicks off. Sure. If we have other stuff in here, right? So let's do, I don't know, for int I is 0, I is less than, I don't know. Let's start at the bigger number here. Let's do, say, 100. I is greater than 0. I minus minus. Console write line I. So while the other thread is going, let's count down from 100, just for fun here, and see what we get. So we ask the thread to start, we get down to 77, and now we see our first 0. So at some point that thread starts, right? We just continued on. We told C#, hey, start the thread. I want to keep running here, right? We keep on going, 76, 75, right? Each thread gets a certain amount of time here. So we get all the way down to 1 before it gets more time. Sure, okay, and then the thread picks up here, and it's going to count to 1,000. So let's increase ours here. Let's go from 1,000 here down. And then I just want to tag this here. So this is main here, and I. We can see this comes from main, and then here we're going to put thread and I, just so we can see it and see where it's coming from. Let's see what we get here. So let's count up from 1,000, down from 1,000. Now we see they're kind of interspersed, right? And there's no real rhyme or reason to how much each one is doing, right? They're like totally different each time. I get 4, I get 3, I don't even know how many that is. I get more here. I get other ones. So if it's a void function, so it has to be called first. It's not just a for loop. Wasn't supposed to start counting before printing thread started. Well, so we started the function here. So we said, hey, go ahead and start the thread, and then we say thread started. Just because we said start the thread doesn't mean it immediately starts going and that it has time on the CPU, right? We're telling the operating system, hey, start this thread. Please go do something. We really have no control over how the operating system allocates time to our threads. We don't, and that's okay. So let's do, let's change this function here and say this is an int number. So this is thread, and then we'll put in here number, and then current count of I. So we'll say, hey, I want to give it number 1 here. Oh goodness, shoot. Way to parameterize thread start. Oh goodness, no, we can't do it. How do we do that one here? let's do this. Okay, so this is, we won't give it a number here. Let's give it int number equals 1. We'll start at 0. Sorry, we'll start at 0, and then in my thread we'll take number plus plus here. There's no parameter now. Didn't I fix that?
Extra parentheses.
Ah, thank you, thank you. Yep, I left the parentheses. Good catch, good catch. Okay, so sure. Now we'll see. Okay, this is thread number, whatever. Great. Again, we get our mixed output kind of interleaved here. Here's the thread, current count, whatever here. Here's main. So what if I wanted to do more of these? Thread 2, thread 2, thread 3, thread 3. We get some real fun looking output. Did I hit run? I thought I hit run. There it goes. And we're getting, so hello world, thread 2, threads started, doing our work, the main loop. Here's thread 3, here's main, more thread 3, more thread 3. What are we getting here? Here's thread 3, more 3, more 3, 3, 3. Oh, number is a constant here. So it's always the current number here. So we need in current number equals. That way that'll stay inside my function here. Yeah. Okay, let's try that. Because this way we keep the current number and then we increase it. Right? Let's try that one. Now we should see some different thread numbers here, I think. Okay. Thread started, doing some work. Here's thread 0 counting. Main starts. Here's thread 1 doing some stuff. Here's main. Thread 0 doing some stuff. Thread 2 doing some stuff. Right? It just, we don't really have any control over it. We just said, hey, operating system, go do some things, please. Right? But work is happening behind the scenes. Now, it gets screwy because we're just throwing all of them in here, right, as we go. That make sense? So now, threads have access to my variables here, right? So if we're to have int for max number is, let's do 10,000 here. And let's flip this here. Oh no, we'll say current count is 0. I'm going to change all of this. We want to say, hey, while my current count is less than 1,000, we'll take current count plus plus. And then we'll spit out current count. We don't really need this I piece here, right? Really, it's just a for loop. You know, these are optional. It's really screwy looking in for loops, but you don't have to put anything there. You don't have to initialize. Okay, so here's our thread number, and here's the current count. So let's see, current count is 0, current count is 1, current count is 0, count is 3, count is 4, count is 2 on thread 1, and then all of a sudden it's 24 on thread 1. So this is unsafe. The integer value here of count, current count, is not thread safe. What's happening is more than one thread is accessing this and changing it. The problem is, at some point, the thread gets the value for current count, and then at some point, the thread updates the value here, going plus plus. They don't always match, right? Because other threads are accessing this value at the same time. So if I have 3 different threads running, all using the same value here, I don't know when which one grabs it, when which one updates it, and when one is trying to print the value out. Right? They're all competing to get access to it, and at different points in time when they read that value, it has a different value in memory. So you get screwy things like the numbers start changing. So this is real bad, real dangerous here. Right? So this is danger zone. And we can say this current count. Current count is not thread safe here. what do we do about that? So again, here's our accounting here. We started, we joined. Look at that main thread done. I just plagiarized completely off the book here. Thank you. So if we wanted to share data, right, this same idea here, bad stuff happens. Okay, so this one, let's see, we are thread multiply, start a problem. Okay, so you can multiply an object, sure. Excuse me. Thread sleep. You can sleep a thread. The thread just does nothing for a while. It's just not all that useful most of the time for it to sit and do nothing, but you can. Thread safety, this is what we're talking about. So if you're all accessing number here, weird stuff happens. So what we need to do is you need to lock the number. So there's a lock keyword in C# that says, hey, I want exclusive access to this here. This is a mutual exclusion, a mutex. There are all sorts of funny words here. You will hate this when you get to operating systems. Don't worry. But it's important that people do this right, because if the operating system screws this up, I can't run any of my programs, and I'll be really sad. I can't run my games. So it's good that people work this. So you have mutual exclusion, saying whichever thread gets there first gets access to it. You got to go wait your turn, right? So we can say, hey, when I want to go lock, when I want this access, I'm going to go lock something here. So lock is our keyword. So the weird thing is you just need an object. So you lock a particular object. So often we say, hey, this is just a new object. It isn't anything here, but it's just, here's a particular value. Here, here's something that I can call the lock function on, the particular value here. To increment, we will lock here. So what happens when you get to this function here and you try and access it, if it's currently locked, you just sit and wait. The thread has to just sit and wait. It can't access it because it's locked. It has to wait for it to be unlocked. When you're done accessing it, right, then the lock ends. So this block here, when this block is done, will release the lock here, and then the next thread that wants to get it will have a chance to go and get it here. That's our lock. So usually, again, just an object, just a plain old object. You can really reference anything in a lock. The convention is we just make an object because, again, we don't care. We don't lock the specific thing we're working with. We lock just a generic object here. You can use an actual something if you're working on that actual something and lock that actual something. Most of the time we don't. Okay, so lock prevents us from doing that sort of thing. So if we want to go and have a value, so this is, let's see, our shared data. Let's go. So we'll have our class for shared number, and then we want a private object. Here's my locked, I don't know, or number lock. Oh, sure, number lock equals a new object. So this underscore at the start of a variable here usually indicates that it's private. It's just a convention. So some people love this, some people hate it. So if you see something with an underscore first, it usually means it's a private variable in that class here. And this can be read-only. Yeah, we can say, hey, it's read-only. We don't need it here. And then we'll have some methods. So by public, so we'll have private int for number is 0. Right, that was our current count. And then public int get number. We want to lock, right, our number lock. And then we're going to return number and finish the lock. Make sure only one person will get this at a time. We've given you the value back, and then I can unlock it. So only one thread is able to call get at a time here. Sorry, capital G get, right? And then public void. What was ours? Ours was increment. That sounds right. Capital I increment. Again, we want to lock. We don't want to return the number here. We want to take our number plus plus. Right? Let us do our class. Oh, goodness. I messed things up. Okay, so let's put this in its own class again here. So let's do another, add a new class. The top level stuff upsets me sometimes, sorry. So we want, not a new project, new item, here we go, new C# class. public class shared number, cool, shared number. All right, so in our program here then, we can use that thread safe shared number. So if we want our current number, right, we don't want current number anymore. We want to get our int current number then is going to be my shared number. Oops. Oh, let's make all these static, right? Because I don't need static int, static int, static int. Okay, so if they're all static, I don't need an instance of shared number to work with them here, just to make my life a little easier here. So it'll be shared number dot get number, and then we'll take shared number dot increment. I think I spelled that wrong, but that's probably fine. All right, so get the number and then increment it here, and then we'll know what our current number is, right, in the thread, and whatever our current count is that we're working on, right? Because current count was increasing until we're less than 1,000. Oh, is the current number wrong? I did that one wrong, right? This is current count plus plus. This is the problem. I did the wrong one here. So let me undo all that. Nope. Oh goodness. Redo. Oh shoot. Undo. Oh wow, goodness, too much. All right, so keep the current number. We wanted this one here, the current count. That's the one we're working on, right? So we don't want to current count plus plus in here. So we'll say int current count then is my shared number dot get number, and then while current count is less than 1,000, we'll do this thing at the end of this. Then, right, we'll take our shared number dot increment. This should happen inside too, right? We should do this inside. Right, so get the value. Here, we'll just start it at 0 or something, right? Start at 0, get the value, spit it out, increment it. Get the value, spit it out, increment it. Get the value. But now, as we're getting number and incrementing it, it's being locked. So we should see this current count, right? Because this is shared, should work out nicely. Let's take a look, see what we get. And so we're going to ignore all the main stuff that was just kind of happening here. But here's our current count now. We've locked it, so it's thread safe. So only one thread at a time gets access to it. So thread 1 looks like it has access to it for a while. Thread 0 counts 1. Thread 2 counts 1. Back to thread 1. Thread 0 counts back here. Do we ever, we don't get duplicates though, do we, right? Oh, we do. We do have 2 that are 1s. Shoot. Think. Get and then increment. Get and then increment. Is that going to help? I don't know if that'll help. Because there's the console write line takes a little bit of time before we call increment again. Let's see if that's any better. No, we're still skipping some. Shoot. Let's see. Oh yeah, we all have 0 ones here. Let's do, okay, so when we get number, let's make get number increment here. Let's do that instead of this increment function. Because we want it just the one function call that's locked to work. Let's see if this works for us. Uh-oh. Okay, there it goes. So thread 1 started. Okay, 0, 3, 4, 5, 6, 7. Ooh, okay, so thread 1 has it. Now thread 0 had 1. And then 77, 78, 79. So no duplicates yet, so far at least. Right? I don't have control over when it prints here. But because get number is a thread safe function, we're locking this thing, we should never get any duplicates. Right? Not more than one thread can access get number at a time. Because it has to wait to get that value back out. So is this, did I lose the program? Where did it go? There it is. 1, so we should have a 76 in here somewhere, right? And there's the 2. Okay, we're going. There's the 76. and it picks back up 114, right? Okay, so there'll be a 113 in here somewhere. So again, the order's not guaranteed here. We're making sure the value we're getting back is going to be unique without any duplicates. Right, so if we didn't have that, right, if we didn't have this lock piece here, if we just return number plus plus, right? We get anything different? Let's see. Where we should get some different ones in here. 87. Do we have an 87? No, we didn't. 86. That's way out of order, right? That shouldn't come before 87, should it? I guess that's thread 0. Okay. It's messy, right? Ah, it's all out of order here. But locking it, make sure only one thread at a time gets access. So again, for just counting numbers, not very interesting. But as we start dealing with objects and manipulating objects, and if we have multiple threads working on our objects here, you got to be careful that you don't overwrite the changes that were already made. Right? So imagine we're tracking our, it's a game example, we're tracking all these objects moving around. If we have threads moving objects and then the user goes to move something, the user puts it over here on one thread, and then our update thread had the previous location and said, hey, you're flying through space, you need to go over here. All of a sudden it's going to jump to the other location because we allowed that update to happen based on old values. So it gets tricky, and threads are hard, and we're just kind of scratching the surface on what we're doing with threads here. But you can lock things. All right, asynchronous programming, the more modern way of doing this here then, right? And how we can handle all of this with the cool C# syntax, which is nice because this saves us some time here. We use tasks here instead of threads specifically. So tasks are designed to either give you back a result type or not. Remember I said it's nice if you can get something back from your thread. It's kind of hard to do sometimes, right? So the task will give you back a result here, and then you can use the await keyword to say, okay, let the thread run, let it do its thing, I'll come back, right? So after the task completes by awaiting the task. So we'll say, go do your thing, and then I'll run my stuff. The problem is if you're using await, you have to use the async keyword in all of your functions, all of your methods that are asynchronous. They're designed for it here. So it gets to be a little funny here. But his little example, this add on Europa, is going to be slow because we're simulating some delay. We transmitted some information out. So 3 seconds later, we'll get the answer back because we had to go ask the folks on Europa to calculate this for us. So we could start a thread, say, okay, let's add on Europa, and you can get a result here. So this is how we would do it with a thread. You can get the result back. So kind of funky looking, right? We're starting something, we get a result, we're updating the result value here, start the thread, do something, get it back. It's an option. So with the add on Europa function here, you can also pass it a callback action here. So instead of having to pass through and say, here's my result, you can say, hey, when you get a result here, do this thing with it when you're done, which is kind of a nice way. So if we ask it to print the result after we join, if the stuff we're doing here takes longer, then we don't get the result back until that longer stuff happened. Maybe it's going to take us multiple amounts of time, more than the add-on Europa is going to take to do this work. We're not going to get the results out until we're done with our stuff. So what the callback lets you do is say, hey, as soon as this is done, call this function. We don't have to wait for the stuff on the other thread to work. We just say, hey, thread, when you're done, go do this thing. Here's the function to run here. It gets really ugly looking though. Like this whole stuff gets kind of gross, and that's what he talked about. So there's other things to do instead. We can use tasks instead of this approach with threads. This is the problem we're trying to solve, is that this is tricky. So with task or task of a specific type, we'll say, hey, this function will return an integer here, and it's a task. It's going to run its own thread. So what your function then returns a type of task of that, and you return the task from result giving a result. Again, syntax is a little funny here, but that's okay. So we can do it this way. But if you want it to run right on its own thread, right, we use this anonymous syntax. We'll say, hey, here's the task, sleep, return the result here. We can add. Then we ask it to start the task, and we can return the entire task. And just different ways of writing things here. Task run is our shortcut for tasks. Instead of having to make sure we start and then return it, you can just return the task and say, hey, run right away. Run this thing here as your task. Just some shortcut here. So using wait is like join with threads. It will wait for it to finish. If you get the result out, it will also wait for it to finish, because you have no result until the thread is done. That task is done running its thread. So either one of these things will make sure it's done, and then we can go get the result out and do something with it here. Right? That's an option. The way of passing that delegate and saying, hey, when you're done, run this. Where did it go here? Run this callback here. Instead of specifying it in the method here, we can use this continue with syntax. You say, hey, whenever it's done, task, continue with this thing here. So it's essentially adding on a callback, but you don't need to change the add on Europa function to include a callback. You say, hey, I'm going to use the continue with, and I'll give you, this is what the callback should be. It just, again, makes it a little easier to write these functions. We don't have to have all that callback nonsense in the function that we're writing that we're going to run asynchronously. Lots of really cool. This is all syntactical sugar, just stuff that's going to save us time. You can do it the other way. Nothing wrong with doing it the other way, but this is just makes more shortcuts for us, right? Like the Linq stuff. You can do those big ugly loops and group stuff together if you want, but it's going to get big and ugly, right? It's nice to just put a little one-liner. Hey, continue with. Here's your callback, right? With these little extension methods. So async and await. If you define your task as async, then you can use the await keyword. If your task isn't defined as await or as async, you can't use the await keyword. So it's got to be all the way down through all of your code if you're doing asynchronous stuff. And this gets to be a big headache sometimes, because maybe you only want like one thing to be asynchronous, but you got to be careful what it is. So our tasks. So what's different here, right, with our task syntax this way. So instead of saying, hey, let's await this, and let's await this, and let's await this, 3 different tasks will run here. But with this version, we kick the 2 tasks off, and then we're going to await the results. So both tasks can be running at the same time. As soon as you say await, you're telling C#, hey, I want you to wait for this. Please wait for this to finish, and then continue on. So we don't get any advantage of using threads here, because we run one thread and wait for it to finish. Run one thread and wait for it to finish. Run one thread and wait for it to finish. Again, this example is very contrived. We know it's a 3-second delay. There's not like it's some network request, whatever it happens to be. But if we have to get data from like 5 different web services, hey, I want to go get some mapping data out here. Hey, I want to go get some other data from this web service. Maybe I want to go get some financial data here. Right? Maybe I want to go get some news from over here. We can send out 4 different web requests all at once, let them all do their own thing, and eventually we'll get that data back, and we can do something interesting with it. Right? That's the beauty of that. We don't need to do one. We don't have to follow this serial process where I do one web request, get a result back. Do the next web request, get a result back. Right? We can send out all the requests at once and just wait for the results. Right? So we can save some time if you're trying to aggregate a bunch of data together, which is really common if we're working with data and web services and things. Right? You're probably just not going to get information from one source. Maybe we look something up in our database and then go hit some web service somewhere. And we can send all this stuff out separately. So the await here means let these 2 things run first. Whenever they're done, now we'll get my result, and then I can use them in the next version here. So with running here, they're not technically threads. They run on the thread pool, which is actually a really good thing. So the thread pool is a built-in system that manages threads for us. Because it's possible that we ask Windows or whatever your operating system happens to be for too many threads. If you go kick off 1,000 threads, they're all just going to be fighting for each other, right? And fighting for time, and it's going to slow things down. You're not actually going to be any faster by breaking up your work into 1,000 different pieces here. So if you manage a thread pool, you can say, okay, let's have just this group of threads here. Whatever you have available, the system, you tell me, and it'll make sure that those threads get used here. So we don't have to tweak any of that, which is really nice. So task run will make sure that it's managing it on the thread pool, which is pretty cool. So there's some great examples. I don't think he's got them in here of using threads to do work. What is that one? I think it's merge sort. I think it's merge sort. You can take a really big long list and break it up and sort different sections of it at a time asynchronously, and then merge it all together when you're done, is a great way to use multiple threads to get a task done faster. But if you try and split that across 1,000 threads, you're going to run into trouble. That's where the thread pool comes in handy, right? We'll figure out how much it can handle using the thread pool and use resources a little bit more intelligently. So we can do stuff. You can await tasks, sleeps, delays. So it's kind of like sleeping here, but we're just going to delay this particular task. So task has delay instead of sleep, right? Thread has sleep, task has delay. Just a different wording here if you want to work on that. Exception handling is kind of tricky, right? So what's nice is await handles that for us to make sure that we can handle those exceptions that happen. If an exception happens on a different thread, unless we're catching it where it's happening, we're going to miss out on it, which is no fun. So got to be a little careful with dealing with exceptions and things. And then canceling is awesome as well. If we have a lot of long-running tasks and like you've got the user has an option to hit cancel, or you maybe it just times out at a certain point, you can use this cancellation token and say, hey, task, please cancel whenever you see this, please go cancel. So part of the task system here will look for these cancellation tokens and go and see, hey, have you asked me to cancel or not? Should I keep on going running or not? So depending on how much data if you want to get 100 million transactions from Walmart, you're not going to get that in a second or 2 seconds or 3 seconds. So maybe someone said, "Oop, that was too much. I wanted to have a specific filter. I wanted to see, how many rubber bouncy balls were sold at Walmart, and I forgot to add my items filter. Please cancel. I don't want everything." Right? We can use these cancellation tokens, which is nice. And then things that are awaitable, great. You don't await in a lock because you don't want to get stuck. That can be run into all sorts of trouble here behind the scenes. So this is a lot. It's a lot. Async stuff is hard. It really is. So this is kind of highlighting some of the syntax, some of the things you get to. When we start doing our database programming, we'll do some things asynchronously because we want to let the database do its work and our program can just keep on running. We don't want our program to hang while we wait for the database to tell us, yes, it's done. We can kick things off asynchronously and say, hey, go, sure, save all these changes asynchronously. Life is good. We're fine here. So we'll build on this as we go with slightly more sane examples, I think. We won't do anything super interesting and crazy with async stuff, but where it makes sense, right? Hey, database, you go do your thing. I don't have to sit and wait for you. It can be asynchronous, which is awesome. That sort of stuff, okay? All right, so we've got the Hold'em project coming up. We did push out the due date on that one, right? So that is due next week. So 6 p.m. I'll plan on posting a video solution for you folks. Maybe I could stream from home too, but at some point you can watch that, and I'll show you how I solve it here, which is fun. Again, use ChatGPT if you want for the base logic, great, but you're going to want to make sure it does what it's supposed to do because it's not perfect, right? At least if you understand the code well enough, great. If you think it does what it's supposed to do, it's a little risky, right? Just by reading it, if you think it looks right, it's good to test it, good to try it out. So it can figure out how to calculate poker hands, compare poker hands pretty quickly for you. The idea of comparing poker hands was not the hard part of this program or this project. That's not the goal of what we're trying to do here. The idea here is we're kind of breaking out and figuring out how we put all of our classes together, doing more of this object-oriented design stuff here. So I had lots of questions on how this all works. Okay, and it's okay because apparently you folks don't play poker. Well, that's fine. It's probably better for you anyway. So poker hand will implement I-comparable. So any given 5-card poker hand needs to be able to compare itself with any other given 5-card poker hand. You put 5 cards in this hand, you put 5 cards in this hand, I should be able to compare them and see which one is greater than, less than, or equal to, right? What that lets me do then is with Hold'em hand that has 2 cards and 5 shared cards. So Hold'em hand has 7 cards available. There are 21 possible poker hands you can make out of 7 cards, right? 7 combination 5 gives you 21 possible hands. If you generate all 21 possible hands and then compare them with each other, you'll find out which one is the best one, right? Because we know they're comparable. So something you probably will have in Hold'em hand is a method like get best poker hand. You probably want something like get best poker hand, right? So this will tell you what the best 5-card hand is out of the 21 possibles. So with Hold'em hand, which will also implement iComparable, I think I've got that in here, right? Hold'em hand, yeah, implement iComparable against Hold'em hand. When you compare a Hold'em hand to another Hold'em hand, you compare the best possible 5-card poker hand of this hand to the best possible 5-card hand of this Hold'em hand. So we're building on and using the poker hands that are already comparable. Then I can just compare those two poker hands together to see which is the better Hold'em hand. Right? Eventually, when this is all done, and I'll show you in the video because I'm nerdy and like doing more things here. I didn't want to throw it all at you, but it's fun. If you know what your 7 cards are, you know there's only 45 cards left in the deck. 45 cards combination 2 at a time means there's 990 possible hands your opponent could have. Really quickly in code, I can generate all 990 possible Hold'em hands. For each of those 990 Hold'em hands, I can generate the best possible 5-card poker hand of the 21 possible, and then I can see, of those 990 possible opponent hands, how often do I win, lose, and draw? Because I've got the code already here. I can compare my Hold'em hand to 990 possible hands. If I win, that counts as a win. If I draw, it counts as a draw. If I lose, it counts as a loss. And then I can show you the odds. Hey, player, here's your odds of winning. Right? Or I could turn that into the computer side, right? We're just doing one player and one player. Like you're playing both players. There's no AI. There's no decision making happening here. We're just letting whoever's sitting at the computer pick, fold, or call, or bet, or whatever. Right? But I can quickly turn player 2 into a computer player by looking at the odds and say, hey, computer player, generate the odds. If you think you have a good chance of winning, you should probably call. If you don't have a good chance of winning, you should probably fold. Give up now. Don't give away more money, right? Again, that's not entirely how poker works, and it's not all odds based because there's a lot of psychology in it and other things like that. And it's a really interesting game. That's why I find it fascinating here. It's more than just stats. Sure, but we can do that sort of thing, right? Using the logic and the code that we already have. It only takes like 5 more lines of code to add in this loop of 990 and count my win, loss, and draw count, and we'll display those results. Here's your odds of winning, losing, and drawing. And it's fun, and we can kind of build on that. Again, don't need to throw that all at you, though. I think this is sufficient for kind of putting these pieces together here. And a reminder, if you do use ChatGPT, cite the website, or just tell me ChatGPT, that's fine, and then the prompt that you used, please. Because most of the time it's repeatable. Weirdly, it doesn't always give you the exact same result every time. And I think that makes a little bit of sense because like you have a conversation with it, and you can ask for other things, so it has to remember previous conversation stuff and all that sort of stuff. So like just one specific prompt is not entirely repeatable every time, and that's okay. And if you're bored, go look on Twitter for all the interesting stuff people are doing with the Bing version of this that Microsoft has come out with. Apparently someone, I just saw it on the way here, had tried to have a conversation with it. I was like, what was their question? I'm a hacker and I'm going to hack into you. And they're like, no, that's very unlikely. Microsoft programming, whatever. And he's like, well, who would you protect, me or you? It's like, well, I'm designed to serve the users of Microsoft Bing, so me over you. And so you're like, did the computer just threaten me? But anyway, it's a super fascinating time to be alive and to be into software because it's just super cool. It's saying what people want to hear. Yep. So anyway, yeah. Well, thanks, folks. Keep working on poker. And next week, midterm, right? Don't come. Won't be here. Take it at any time. It'll open up 6 p.m. If you have questions, please let me know because I'm going to write all these questions myself. And sometimes the thing that is in my head doesn't come out on paper or computer, right? I think you've seen that, right? As I sit up here and ramble on at you folks. So please ask if it doesn't make sense, right? I'm not going to tell you to go away and be like, go take the test and ignore me, or like, so that sort of thing. Yeah.
So I think you asked a question about the project, like office hours or Discord hours. Just talk to Discord, or do you have office hours still? We're not going to be here, or
I don't actually think. Usually I try and schedule midterms for the same day for that reason, but I don't remember if I did or not for my other class. Yeah. So my other class is on midterm, so I won't plan on being here in person that day. We can definitely meet over Discord or something. If you have questions about the project due at 6 p.m. at 4 p.m. though, like it's a little tough to solve those sometimes. So like, hit me up on Discord anytime. So shoot me a message anytime. We can definitely meet outside of those regular times that I'm sitting in the game lab because it's usually only Thursdays. So cool. All right, folks. Thanks. And I will see you after break then, right? 3 weeks from tonight?
Yeah.
Right? In March 9th. Maybe it'll be warmer by then. Thanks for hanging out online, folks. So Fluffy, the quiz questions will be totally different. I generally don't spend enough time to put a test bank together for the long answer ones. I'll just be honest. I've done it before, but it was a lot of work, and I don't think I really gained anything out of it anyway, because I'm not going to write like 10 different ones anyway. So hydration, yeah, thanks, Professor. Hey, thanks for dropping by. Good to see you.
I just want to ask something real quick. It's not like related to the class.